and welcome to Entity's Developer Workshop for the X-Day 2023 Hackathon. Before diving into the topic of building hybrid apps, we wanted to briefly introduce what we do at Entity. Entity is a fully compliant growth engine for Web3 builders and investors. With the Entity Launchpad as our core module, our mission is to help launch the next generation of blockchain innovation. At Entity, we look forward to supporting the next wave of DeFi pioneers throughout the X-Day Hackathon and beyond. In today's workshop, we will guide you through Web2 and Web3 authentication techniques and how to use them for building your MultiversX dApp and accelerating product development. So, without further ado, let's get started. First of all, what is a hybrid app? In our context, a hybrid app refers to a combination of both Web3 and Web2 architecture. This way, it's possible to store important data both on-chain and in an internal database. This approach leverages some advantages of centralized web infrastructure while also embracing decentralization by storing data on the blockchain. Why did we have to build a hybrid app at Entity? Our requirement came from the need to store mutable data obtained from various webhooks and external APIs while also providing real-time updates to the connected users regarding their different statuses on the Entity Launchpad. So, how did we do it? For the Web2 structure, we stored the data inside a Mongo database through a Backend API, NestJS in our case. And for the Web3 structure, the standard procedure for supporting a Web3 application typically involves a collection of smart contracts linked to the front-end framework via a proxy gateway. User authentication is carried out within the front-end framework, and you must install the MultiversX SDK dApp library to enable this functionality. Upon successful authentication, users gain the capability to store funds and initiate transactions on the MultiversX blockchain. To facilitate the transfer of user identity data from the front end to the back end, it's necessary to incorporate the native auth libraries offered by MultiversX. The native auth client library will generate a JWT token, which is then transmitted to the backend framework. Subsequently, we can utilize the native auth server library on the backend to validate and decode this JWT token. You can discover additional information about the native auth JWT token, including details about the encoded and decoded payload, on the following website, utils.multiversx.com/auth. Now, it's time for the practical segment of the workshop, where we will construct an example of a hybrid app as we have just discussed. The initial step is to fork and clone the MX template dApp repository from the MultiversX GitHub. This dApp template incorporates the SDK dApp library, making it simpler for developers to start their dApp development journey in the MultiversX ecosystem. During this process, we recommend taking the opportunity to explore the SDK dApp library and discover its impressive array of features, ranging from tooltips to hooks and other valuable utilities. As for the second step, you will need to install the NestJS framework on your local machine. Simply refer to the documentation available on their official website for guidance, nestjs.com. We won't be demonstrating these first two steps here today, as I've already completed them on my local machine. Additionally, we won't showcase all the pre-existing components in the MX template dApp. Instead, we will focus on detailing the essential configurations that need to be completed in order to integrate native auth features into the user authentication process. So, let's set up the right native auth configs. First, you'll need to generate your Wallet Connect project ID. You can accomplish this by following the link provided in the configuration file. Additionally, it's crucial to verify your domain with Wallet Connect as part of this process. Next, you should include your API URL in the sample authenticated domains constant. The Axios interceptor context found in the app module is responsible for monitoring all app requests and appending the bearer token to the request header if the user is authenticated. Please note that any URLs added to the sample authenticated domains configuration constant must be HTTPS enabled. Also, if you have an older version of the MX template dApp library, you will have to check the unlock component and set the native auth flag to true. Now, let's turn our attention to the Backend framework. To start the Backend server for our example application, we simply follow the instructions from the README file. First, install the necessary dependencies using the following command, npm install, and the additional flag force. This is mandatory since the current MultiversX libraries do not support the NestJS 10 version. After that, just make sure that you have the config.yaml file in the config directory. You can use the config.yaml.sample file as a reference. Then, you need to generate the certificate because we are going to use HTTPS. You can use OpenSSL and the following commands to generate one, but of course you can also use another tool that you prefer for this purpose. On our server, we're going to store some user metadata. For this metadata, we are using Mongo database, so make sure you also have MongoDB in place. Coming back to the configuration file, we will use the DevNet API. So we will have the blockchain network pointing to the DevNet, and for the URLs, we are using the MultiversX API. Please be aware that the same API needs to be used on the backend side as on the front end in order to avoid the block hash exception. We are also going to use a course policy, and for local development, you can just enter a star here in configuration to grant access. For the database, you must update the connection string and set the database name if this does not match your case. The accepted origins are the ones from the local host, since we are launching the applications on our local machines. Feel free to take a moment to pause the video now and do the preparations. If everything is set up correctly, you should now be able to start the server. You can use the npm run start command and the additional flag to start the server in development mode, and you can also find the instructions in the package.json file. Simply trigger the command and check the logs. If everything is fine, you should find application is running on localhost port 3000. Great, so far so good. Now let's take a second to briefly analyze what we just started. We have in the main.ts file the start of the server. Using the newly created certificate, we are starting a Nest application. Additionally, we are setting a global exception filter, some validation pipes, and enabling the cores. Considering the project structure, we have several common modules. The API config, which is a service that reads the configuration properties from the YAML file, the authentication modules, and the database modules, which also include the global exception filter. Since you can find them on GitHub, we will skip them for this session, but feel free to check out the source code. Next, we will focus on the authentication and the way Web2 works alongside Web3 to provide a secure method for validating the user on the backend side. When a request is received on the backend, several things are done under the hood before the code of the service will be executed. Certain guards are already configured. The first one to be considered is the native authentication guard. Basically, if the endpoint is not decorated with a public decorator, the next strategy will be executed. The native auth strategy is the most important one since this actually validates the authentication token or the JWT coming from the front-end side. For that, we are using a native auth server that considers the configuration we have for the API URL, the accepted origins, and the expiration in seconds. Just make sure that the accepted origins are HTTPS URLs. This strategy validates the token. So, the bearer token will be extracted from the authorization header and then passed along to the server to be validated. If it is validated, then the server can also decode the JWT token and get the payload. Having the payload in place, we now know the wallet address. At this point, we can play around considering our business logic and implement what we need based on this address. In order to retrieve the user, we are using the user service. The user, first of all, is checked by their public address. So, the wallet's public address needs to be a valid address on-chain. Next, we retrieve the user from the database. If it exists, we are simply returning it. Otherwise, we just create a new user considering the public address and the user role. We then maintain this user along with the saved entity that it has just returned. You can add different roles considering your use cases and business needs. Coming back to the native auth guard, if everything went fine with the roles guard, it is finally executed. From this context, we retrieve the roles and check for each endpoint if the authenticated user holds a required role. If the roles match, then true is returned. If the execution of the code reaches the service layer, for instance, updating email for the second endpoint, we can be sure that it passed all of the previously presented guards. Basically, the user has a valid wallet address, the token was successfully generated, signed, and validated, and the user holds the necessary roles to access the endpoint. There are other decorators that we have built for custom usage, like retrieving the user's metadata from the context. You can check the custom decorator in the decorators directory. On one hand, the first endpoint covers the needs for the Web3 side to authenticate and authorize the user. The second endpoint covers the needs for Web2, such as updating their email address. Now, let's take a look on the update email implementation. First of all, we are checking if the email is unique by counting the total emails already registered in the database. If there aren't more, we can proceed with updating the email address for the corresponding user. First of all, we are validating the user ID, retrieving the user by this ID, proceeding with the update function, and then updating the user in the database. For your project, feel free to add more implementations considering your business logic and your different use cases that combine Web 2 and Web 3. Now, let's initiate the testing phase of our example application. To commence the front-end framework, execute the command npm run start. And for the backend, launch the project using npm run start debug. With both the front end and back end running smoothly, we could proceed to test the application using the Chrome browser. In order to determine if the request includes a JWT token for the apps registered within the sample authenticated domains constant, we must first authenticate using a valid wallet. As you can observe from the outset, there is an initial HTTP request directed toward our backend API, aiming to retrieve or register the user within our application. If we examine this HTTP request closely, we'll notice that there is an authorization header containing the bearer token. This indicates that the Axios interceptor context has successfully intercepted the request and appended the bearer token to the authorization header. We initiated this call using a newly introduced checkAuth component, which is positioned directly below the authenticated routes wrapper. This placement ensures that the call is only triggered when a user attempts to access an authenticated route. The primary function of the checkAuth component is to retrieve the current user's details from MongoDB and subsequently add them into the React context. If we check that in the backend logs, we will see that a new user was created in our database. Additionally, we have the option to visit the stats page, which currently makes an API call to the MVX Tools app to fetch specific data. As you can see, the sent HTTP request has the authorization bearer token set. But now, if we go to the config file and remove the tool API URL constant from sample authenticated domains, in the new API call that the authorization token bearer is missing from the headers. As a side note, you can create your own Axios interceptor for more flexibility. As a result, you can remove the Axios interceptor context. If you opt for this approach, it's important to note that you can access the JWT token using the use-get-login-info hook, specifically within the token login object under the native auth token property. You can find an example of this in our user service. In this scenario, we manually included the token that was accessed in the request header. So, this concludes our presentation. You can access the resources for this demo in the video description, and we are excited to see what kind of exceptional applications you will build on MultiversX with the help of these materials. On behalf of the entire Entity team, thanks for your attention and good luck in the hackathon!